Section 12.2, Arithmetic Sequences, focuses only on sequences, which we learned last time was a list of numbers, that have a specific pattern. And that pattern is that your first term is a or a sub 1, and every term is equal to the one before it. Remember, this means n minus 1, the one before it, plus a common difference. So right here, that's the common difference that we add over and over again. So how can I show that this is arithmetic? When you take a look at your list of numbers, you'll notice that it's 4, then 2, then 0, then -2. And what's happening every time is that to get from the first number to the second number, then the second to the third, and the third to the fourth, you have to do the same operation. What would you have to do? You would have to subtract 2 over and over and over again. That means that your common difference is -2. And of course, your first term is 4. But what if I didn't know the common difference? What if I didn't look at it and just be able to tell? Well, you pick any two numbers that are beside each other. Any two will work. And you take the second number minus the first number. And that will give you the common difference. Now, if it doesn't work no matter which two you've picked, then you don't have an arithmetic sequence. Every once in a while, though, they don't give you a list of numbers. They give you a formula. So you have two choices. You can either create the list of numbers. We can find s sub 1, s sub 2, and this is a lowercase s. That's important because later uppercase s means find the sum of. But s sub 1, we would plug in 1, and 4 times 1 minus 1 is 3, and s sub 2 is equal to 4 times 2, which is 8, minus 1, which is 5. So the first term, s sub 1, is equal to 3. But what is the common difference? This would be the first two terms, so that's 2 in a row. We take the second one minus the first one, and that common difference I just noticed I made a mistake. This particular number right here, if I plug in 2, 8 minus 1 is 7, not 5. Sorry about that. 7, not 5. So 7 minus 3 is 4. So let's go back over that again because I made a mistake when I was first talking about it. That if I plugged in 1, 4 times 1 is 4, minus 1 is 3. But if I plug in 2, 4 times 2 is 8, minus 1 is 7. And how far apart are those? So my common difference is 4. Well, let's take a look at the equation. Where does the common difference show up in the equation? It shows up right there. It's related to the slope. And that's because if I were to list this in terms, the term number and the value, the term number 1 and the term number 2 had a value of 3 and 7. And how far apart are those? 4. How far apart are those? 1. And remember the slope, y over x, in this case is 4. It's also the common difference. So let's take a look at this one. I can tell you right now that t sub 1 would mean plug in 1. So 2 minus 3 times 1. 2 minus 3 is -1. There's my first term. And where could I find the common difference? Right there. The common difference is -3. Okay? Well, now that we have that out of the way, this is called recursive notation, and you're not going to have to practice recursive notation, but you do need to understand what it means is that a number is worth the one before it plus the difference. Well, what if I wanted to find a number that wasn't in order? In other words, what if I wanted to find the 24th term? I have the first, second, third, and fourth. I don't want to go all the way out to find the 23rd and then add the common difference. So they've given us a formula for finding the nth term. And the nth term, meaning the 24th term, can be found by using the first term. That should be a sub 1, because back here a is equal to a sub 1. The first term, which we know is -3, plus n minus 1 times the common difference. Well, what is the common difference? Well, what's happening with each of these numbers? The common difference in this list is 3. 6 minus 3 is 3. 3 minus 3 is 0. 0 minus 3 is negative 3. So negative 3 plus 3 plus 3 plus 3, right? And so we're going to multiply that times 3. So that means that we have negative 3 plus 23 times 3. That's negative 3 plus 69 makes that 66. So the 24th term, if I were to list out all the numbers up to the 24th number, the 24th number would be 66. Now, every once in a while, they give us two terms from the list. They say the 8th term is 75 and the 20th term is 39. And they ask us to find the first term and the common difference. Well, remember how I showed you we could make a table of values? Well, let's do that here. Let's say that the term number, the 8th term, had a value of 75. And the 20th term had a value of 39. Well, when we look at that, how far apart are those two numbers? Those are 12 apart. 8 plus 12 is 20. And then 75 to 39 is a subtraction. So 75 minus 36 would get me 39. So what is the common difference? The common difference in this case is equal to negative 36 over 12. That's the slope. Our common difference is negative 3. So now I can find the first term. So let's go and use our term numbers and our value. First term to 8th term, this is 75. How far apart are these? Well, this is 7 apart, positive 7 apart. And so this, using our slope, 7 times negative 3 means I have to subtract 21. So what value minus 21, what value minus 21 would equal to 75? Solve for x, and you'll find that that's 96. So my first term is 96. So to answer part A, says what's the first term? A sub 1 is 96. What's the common difference? Negative 3. Now I told you that we were not going to ask about the recursive term, so we're going to skip that. But what is the nth term? The nth term, right? The nth term of the sequence, we're going to use this formula. A sub n is equal to the first term plus n minus 1 times the common difference. Now you can leave it like this, but we can distribute. We're in pre-cal, we can distribute that out. That equals 96 minus 3n plus 3. Combine like terms, and 99 minus 3n would be the formula for the nth term. And that's what the homework's going to look for on the on the computer. Okay, last section, summation, right? The sum of n terms. We know how many terms we have, and we want to find the sum. It can look like this. It can either be looking at, if we know how many terms, we have a sum of a terms, we have them listed out, and it's this formula, right? We have this formula listed. Well, we can solve it by taking n from right there, divided by 2, 2 times the first term, plus n minus 1 times the common difference, right? That's if we have an n right there. Or we could take, here's the formula, the other method we could use is the n divided by 2 times the first term plus the last term. So it all depends on what we have, okay? So let's find the sum of the first 10 terms of this sequence. So they gave me a sequence. So the first thing I'm going to ask you, in both of these, you'll notice we needed to know n, and we needed to know d, and we needed to know the first term. So let's list that out. The first 10 terms, that means n is equal to 10. I know that I want 10 terms, n is 10. The sequence right here, the common difference, we can find it in the slope, is equal to 4. I now need to find the first term and the 10th term. That's the easiest one to use. First term plus the last term times n divided by 2. So the first term, let's plug in 1. 4 times 1 is 4, plus 2 is 6. The 10th term, 4 times 10 is 40, plus 2 is 42. I now have everything I need to solve this equation right here. I would say 10 divided by 2 times 6 plus 42. That's the first and the last added together, and then the number of terms divided by 2. So I have 5 times 48, which means the sum of the first 10 terms, and that's the way we write it, capital S, the sum of the first 10 terms is equal to 240. 240, okay? Well, let's look at this one. We have the first term. We have a sub 1 is 52. And we have the last term. The problem is, I don't know which term that is. I know it's 122, but I don't know what n is. So in this case, I know the common difference. It was plus 5. The common difference is 5, but I don't know n. So I'm going to go back and take a look at this formula with the n in it. And I'm going to say n divided by 2. I can leave that, n over 2. I don't know what that is, right? Times 2 times the first term, which is 104, plus n minus 1 times the common difference, which is 5. And if I could figure out n, I would know the sum of the first n terms. So I still need the n. How do I do that? Well, let's take the formula for the nth term. Do you remember back on the page before, the formula for the nth term was a sub 1 plus n minus 1 times d? And I know that this term right here is 122. The first term is 52 plus n minus 1 times 5. Oh, sorry, I should have put a d there because I wanted you to see the equation. And then the 5 was the common difference. I'm going to subtract 52. Let me go ahead and do that. Minus 52. And I'm going to get 70 equals n minus 1 times 5. Let me divide by 5 on both sides of the equal sign. And I will get 14 equals n minus 1. Add 1 to both sides, 15 equals n. Now I can go back here, change this to 15, change this to 15, and I will have the sum of the first 15 terms, because n is 15 everywhere it was in that equation. So I'm going to have 15 over 2 times 104 plus 14 times 5. Put that in your calculator, and you will get 1,305. 1,305 is the sum of the first 15 terms, and that's how many terms there are. That's section 12.1. The homework looks just like it. Good luck.